Morning, Miss Valencia. So I'm gonna try to solve the two challenge questions you did. After a bunch of trial and error, I hope it is all right. And if not, I'm sorry, but I tried to be an Asian and not give up, and these are my solutions to it. Today I'm gonna present you a challenge question. It says, why does multiplying by a fraction equal the same as a reciprocal? So I'm gonna give you my point of view on why this works. So here we have an example. Why does 3 over 4 divided by 1/2 the same as 3 over 4 times 2 over 1? So if we notice here, 1/2 and 2 over 1 are reciprocals. So we're going to have to think about what is a reciprocal. So if we look at our algebra skills, we know that 1/2 is the reciprocal of 2 over 1, right? And this will have to do with identities and inverse. So back then they didn't have division. Well, they did have division, but they didn't know it was division yet. So we would have a number, which here we'll call A, and they knew about multiplication. And they're like, okay, well, what number can we multiply this to get its identity? And the identity for multiplication is 1. So they're like, well, we know A inverse, which is equal to 1. And the reason 1 is the identity for multiplication is if you multiply any number, A, by 1, we always get A. So they were looking for something to multiply to A to give us an identity. So if we look at now our fractions, we have a number A over B multiplying by its inverse, which would be B over A. We would get A over B over B over A, which is the same as A over B, which is A over B, which is 1. So you're asking, well, what does it have to do with our inverse? So if we look at it, we kind of notice that division and multiplication are related. So if you're dividing by something, you can actually multiply it by its inverse. So if we put this to our column, we're going to see we have our first number, which is 3 over 4 divided by 1 over 2. And we all know that that would give us 1.5 if we put it in a calculator. But if we do our reciprocals, we have 3 over 4. Instead of dividing, we're going to multiply it times 1/2 inverse, right? Well, if we know inverse, we know that we just have to rotate the fraction. So we're going to have 3 over 4 times 2 over 1, which will give us our answer, which is 6 over 4, which is the same as 3 over 2, which is 1.5. So this is why I think multiplying as reciprocal works. Hello everyone, so this is our second portion of the challenge questions. This is our second challenge question, and today we're going to try to answer, are there two 3-digit numbers that sums a 4-digit number without any digit repeating? So this sounds real crazy, but if we write it here, it's basically asking if we have a way to add, let's say our numbers are A, B, C, D, E, F, we can get G, H, I, and J without any digit repeating. So this actually took me like 2 days to figure it out, and here was my solution. So the first step I always do is I write our numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So I know we have two 3-digit numbers, so I set up the equation. So the first numbers I always look at are 0, 1, 8, and 9. So these four. So I know 1 is going to have to be our digit here that goes in the thousand place, so I do that. So before I would think that 9 would go here, 0 would go here, and 8 would go here. But it wasn't until, I believe, a couple days ago, I realized I was actually wrong. It's a lot simpler if you go 10, 9, and 8. The reason being is we already have 4 numbers, right? So we're left with only the numbers 2 through 7. And I'm like, okay, well, I choose what combination gives us 10, 8, 9. And I was like, okay, well, 8. I know 6 and 2 will give us 8. So I know it's 6 and 2. So I cross those out. And then I'm like, okay, well, 9, what gives us 9? Well, I know 5 and 4 give us 9. So 5 and 4. So 5 and 4. I was like, okay, 10. Oh, awesome. I have 7 and 3. So 7 and 3. So there was a way that we could solve this. And then another hint was, are there any different combinations that we can do? Well, yes, if you move the numbers around, you can actually make 7, 4, and 2, plus 3, 5, and 6. Or you can switch the places of the 8 and the 9. You can switch these places, and you can get another 4 different numbers from there. And then another cool thing is you can actually try, I haven't tried it yet, but you can try to see if you were to play with the numbers and see if you move, I don't know, instead of 3 and 7, you have 6 and 4, and see if you can find any combinations. So this was my solution. I finally figured it out, and I hope you guys had the same luck.
All right, good. All right, it's done.